And we are live. Woohoo! And I have a new puppet. This is Math 75. And this is mathematical analysis for business. And it's the section 6.4, which is the present value of annuities. And I can't remember his name, but it's the pen pineapple guy. And we're having a party. As I record this, City College is in the middle of a giant outage, and all the power will probably be out for the weekend. So yay, pen pineapple. Okay, so what the heck is going on in 6.4, which sounds just like 6.5? Well, in 6.3, I made this helpful card, which I will scan and it'll be part of your notes. I'll just remind you that in 6.3, we have this formula, which is the future value of an annuity. So if we put money into an account over and over again, how much will it be worth at the end? So 6.3, money in, and then we were curious about this amount, which is S. Oops, scooch this over a little bit. And in 6.4, we're actually curious now about the present value, which we're going to call A. You remember that I warned you that some things are P and sometimes they're A. This is one of those cases. To buy the annuity right out, and then the money comes back out until the future. This is 6.4. So 6.3, we're interested in the future value. 6.4, we're interested in the present value. And then the difference between money in and money out. Money in means that we're going to pay in. We're like going to save money every month or every year. And then how much will it be worth? So this is saving up for something. In 6.4, we're going to usually buy something. And so this would be buying a bond or buying an annuity. And that is so that we pay for it now, and then we will get money over time. So we're buying a series of payments. I should say payouts, I'll call them. You're buying a series of payouts. So that's the difference, whether we're talking about the value now or the value then. It doesn't actually matter which one we're looking at. It is basically the same formula. So we're going to go back to an ordinary annuity. Remember, an ordinary annuity is an annuity that pays out at the end of every period. In 6.3, we talked about an annuity due. If you hear the word annuity due, that means it's at the beginning, but we're going to be talking about the end. So that's the first thing. The present value of an ordinary annuity is the sum of money required to purchase an ordinary annuity, or the value of that annuity. And you can kind of compare and contrast. It's not as easy as it looks what's going on. They look very similar. But you do see something. We've got the opposite of N here in our present value, whereas in the future value, we have N. We do have 1 minus this rather than this minus 1. So you can kind of see how they're related. But the future value and the present value are going to be useful in different ways. So 6.4 is a present value. And the first thing I want to do is just talk about a very simple, very straightforward application. So the simple, straightforward application: find the lump sum that one must invest in an annuity in order to receive $1,000. So our payments are going to be $1,000. It says at the end of each month, so we know it's an ordinary annuity, so we're okay there. For the next 16 years, the time is 16 years. If the annuity pays 9%, And I want to say, dang, if you can get into an annuity that's going to pay 9%, nice, compounded monthly. So if it's monthly, remember our number of periods per year is going to be 12. So let's look through a few things in the formula. First off, we're trying to find the value now. So A is the value today. And basically, this is an instrument you would use for retirement. You would pay someone some money right now. You say, if I give you this money right now, will you give me $1,000 a month so I can buy groceries? It's kind of like a savings account, except instead of putting money in over time, you're taking money out over time. So you have, how much money do I need right now to be able to withdraw this much money every month? And so we're going to be looking into using this formula. So the things I need to know is I need to know I, and remember that's R over M, just like it was before. So this is 0.09 all over 12, which is really nice. It doesn't always work out this way. Here's the rule. You can actually do this division and write it as a decimal if it's a terminating decimal. If the digits keep going forever, you have to not, you can't round. The minute you round, your numbers are going to start being off. And given that we're going to be talking about hundreds of thousands of dollars, just a little bit, a smidge being off is going to change the answer by quite a lot. So, and you're going to make people with money very cranky. So you want to be very, 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 very careful with these numbers. Okay, so our interest rate per month is this thing. And then we also need to know N, and remember that's M times T. It's the number of payments. So we've got monthly times 16 years. So the total number of months is 192. Okay, so we need to know all these things. So we're doing this the same way that we've been doing things ever since 6.2. The big difference is instead of just having $1,000 and leaving it in the bank or something, what we're looking at is it's $1,000 every single month. Okay, so you're going to have to take my word for it. The formula is right here, but I don't think I have a good way of showing you. I know you get a preview of what's in 6.5. So we're going to use this. Let's see, there's no real good place to put it, but I'll show you. It's right there. That's the formula right there. It's going to be A equals R times 1 minus 1 plus I to the negative N all over I. R always means it's a repeated payment as opposed to P for present value or principal. So then I'm going to go ahead and just plug things in. I've got $1,000 there, 1 minus 1.0075. Now here again, if this doesn't turn out nicely, we would have the big, a bunch of numbers in here. We'd have 1 plus whatever this is. Because again, you don't want to round things. When you're talking about exponential functions, don't round ever, ever, ever till the very end. Okay, negative 192, because that's N. Oh, sorry, you can't see. Oh, there it is right there. There's the opposite of N, so negative 192 all over 0.0075. Okay, so I'm just using a straight application of this formula. On the final, I will give you a sheet with all the formulas. I won't tell you what the formulas are called. So you'll have to be able to recognize the formulas, but I will give you the sheet of formulas, if that makes sense. So it's not an open book test, but I know that chapter 6 is hard because all these formulas are really bonkers. There's so many. I mean, I wrote them all down. There are so many and they're so similar. So I figured the best way to do it is I will give you that handout of all of the formulas, and you will have to do what you would normally have to do when you Google. You'll have to be able to look at all of them together and say, okay, this is the one I need. And I figured that's the closest to what would happen in the real world. In the real world, if you forget one of these formulas, either you would have a fancy computer application that would do it for you, or you'd have to look it up. You'd quickly Google it and you'd have to recognize whether it was correct or not. So that's what I'm going to ask for you to do. Okay, now, honestly, the formula is not the hardest part. The hardest part for this is the calculator. I'm going to give you one suggestion. This is what I do. So 1,000 times, open parenthesis. Some people don't have to put in the times. 1 minus 1.0075 exponent key plus minus key, whatever it is, your negative key, 192, close parenthesis, equals. That goes all the way across the top. So that's the part that is right here, is this part right here. And then this part down here, I'm going to do right here. Then we divide it by 0.0075. And when you do that, you're going to get 101,572.77. Here's my calculator. So you can see I've been working out. So the truth of the matter is, yes, I work things out ahead of time to make sure I've got all the numbers right so that I don't fat finger anything, because these formulas are not easy. So what I'm going to do is 1,000 times, open the parenthesis, 1 minus 1.0075. And in my calculator, the raised to a higher power is this one. Raise it up, opposite sign, 192, close parentheses, equals. And then I divide by 0.0075, the interest rate per period, and I get that amount. Okay, 101,572. Is it? Oh, this was an approximation. It actually, here for the notes, I apologize. I should have written in what they exactly equal. Either that or like I said before, I am so addicted to the correction tape. I love it. I think I'm making mistakes just to get to use it. 7689. Sorry, the original was actually 0.7689, which when you round it goes to 77. Now, why is this an amazing amount? Well, let's take a look at what the problem is saying. In the original problem, it says you want to get $1,000 every month for 16 years. So this is like a retirement plan, right? You put money into this instrument, and then they promise to give you $1,000 every month, so you can pay the rent, or you can buy food, or you can go to Morocco, or whatever you want to do. So if that happens, you're getting $12,000 a year times 16 years, which is $192,000. So why do you only have to put in 101,000? It's a good question. So why do you only have to pay 101,000 now to get $1,000 a month for 16 years? And the answer is, hopefully what you're saying is that it's because, and go ahead and pause this if you haven't thought about it, and then unpause when you think you've got it. You're giving them all the money now. So they're putting this to work. They're investing this and earning money on it. So they're earning interest, and all the interest they earn over the 16 years makes up for the money they're giving you. So basically the present value is always going to be less than the future value, right? So that's this amount. Woohoo. So while I've got a captive audience, I've been talking with friends online. What are annuities? Well, annuities are exactly this. You go to, a lot of times, an insurance company or your broker, and you say, I would really like to put some annuities into my portfolio. Annuities are agreements, they're contracts. And what could go wrong? Well, if you contract with your best friend, Bob, to give you $1,000 every month, there's a chance that Bob will not have $1,000 one month. That's a chance. And then what will you do if he doesn't have the money? Okay, that's a problem. There's also the problem that what if I don't mean to say this, but what if you get hit by a car tomorrow? Then what happens? Well, different annuities have different rules. If you're talking about a pension, a lot of pensions say we will pay you until you pass on. Once you pass on, that's it. We don't pay anymore. So there are definitely risks. Annuities mean you're going to put a bunch of money and give it to someone else. And usually the agreement is you can't get the money back. So for some people, it's very stressful because they're like, well, I invested all this money, but I only get $1,000 a month. So if suddenly the stock market starts going bonkers or gold starts going bonkers or oil goes bonkers and you want to invest in it, you won't be able to get your money back out. So annuities tend to be very they tend to be good for folks who want a, a guaranteed amount of money and they're not worried about high returns, although this one is kind of bonkers, 9%, but they're not interested in really high returns. They just want guaranteed income. So this usually is someone who's older who's interested in this. The other thing to pay attention to if you guys are thinking about investing, which I am not giving you investment advice because it would not be appropriate for me to, but what I would recommend is if you look into annuities, make sure you're paying really close attention to what the commission amount is. Commissions on annuities tend to be very high. So even though you're making 9%, which is amazing, if you're paying 5% commission, you're not making 9%, right? So really pay attention to the commissions that the brokers are charging. Woohoo. Okay, math on. Next one, we're going to be talking about bonds. Bond. James Bond.